Hey, how's it going, guys? This is Max here, back with part 2 of building a Mario game with JavaScript and Kaboom.js. So if you haven't done part 1 yet, go ahead and do that. I will put a link in the description for you. In part 1 we set up our levels, enabled our player controls and our basic enemy logic, and today we're going to do a whole lot more, so I hope you're super excited to complete our Mario game. So let's go ahead and get started. Alright, so let's run our project from where we left off in part 1. So in part 1, we implemented the logic to start our game, obviously. We've got Mario running around, although we don't have the animation yet. We've got our enemy who's patrolling around successfully using our custom patrol component and our custom enemy component as well. And so if you look over here, we can squash our enemies, and that is about it for now. We do have these question boxes up ahead, but if you jump into those boxes at the moment, nothing is happening. So if you're familiar with the game of Mario, you'll know that when we hit one of these question boxes, we need a surprise item to come out whenever we headbutt these boxes. So let's go ahead and implement the logic to do that. So we're going to need another custom component in order to implement our headbutting the question boxes logic. And that's going to be the bump component. Right, so we've got another custom component over here called bump. And if we have a look at the parameters, we've got offset. So offset will basically determine how much we want the little box to move up, essentially, whenever we headbutt it. Speed is obviously just the speed at which that'll happen. And this stop at origin will essentially determine whether we want the box to return to its original position or not after we headbutt it. So if this would be false, it'll kind of look like the box would just be headbutted off the screen, basically. So if we have a look at our bump component, we've got our return object here, of course, as with all custom components in Kaboom.js. So we give it the ID of bump. It requires the pos component to work. We've got a bump offset, which is set to our offset variable, which we'll input here. We're using the original position to track. We've got a bumped variable over here that's set to false, and if you look at our bump method inside the bump function, so it's basically just a nested function over here, this is where we'll set that bumped back to true if we indeed call this bump method. And of course we want to set the original position back to where the Y position was, right? So we've got a direction variable again to track obviously the direction going up and down. Then if you look at our update method, which if you remember will run on every frame, we've got a check in here on bumped. And inside this check, we have a few sub checks basically. So if bumped is true, the first thing we're going to do is set the Y position of that object to equal that current Y position plus our direction, which would be -1 or 1 basically, and multiply that by the speed to obviously get how fast we want that to happen. Then our two checks here basically are checking the current position of that particular question box on the Y-axis, and we're basically just checking if that has reached our offset position. So it'll bump just a little bit up, and then we swap our direction either to 1 or -1 depending on whether it's reached that point or not. And we also want to use our stop at origin variable, which we set to true by default, obviously because we want the box to go back to its original position over here, to set the direction either to 1 or -1, and that will basically create a little illusion of the box being bumped. So that is our bump component. Hopefully this all makes sense. And in order to make this work, we're going to have to do a check for Mario against a box, a collision check, right? So if we go back into our main scene, under we've done this collision detection here, we can say Mario headbutt. So if you look over here, we are doing a check for a headbutt tag, and obviously we're using this on the player object. So we want to pass in an arrow function here with the specific object that's been headbutted, and then we're just doing checks in here on the different types of boxes that the box could be, and we're just doing some different stuff for the different cases here. So if the box is a coin box, we want to spawn a coin, and we're using grid pos, which is a method by Kaboom, to get the current position on the grid of that object, right? And we're going to set a variable called coin to spawn one of our coins, which of course use the little C tag over here. And then we want to use our custom bump method on that coin to bump it a little bit, of course. And then if it is a mushroom box, we want to spawn a mushroom. Remember, we gave the mushroom a capital M tag, and we just want to spawn that mushroom at the exact position of that current box object, right? If we look over here, we've got the position of the current object that's been headbutted. We're just saving that to a variable here, and then we destroy it using the destroy method from Kaboom, right? Then finally, we just want to create a box, which is of course one of those empty boxes. If we look back at our config over here, the exclamation mark is an empty box, right? So now that we have our bump component, we can uncomment all our bump calls over here. Oh, looks like we missed this patrol over here for a big mushroom. Make sure you uncomment that one as well. And we've got a bump over here. So let's uncomment that. And I believe we should be good now. So we have our custom bump component. We have our collision detection for the player on a headbutt. So what we want to do now is save. And let's give this a test. So let's run our project. Let's start our game. So let's try headbutt, a box. Nice. So you can see the coin was spawned in the position that we want on the object that we headbutted, right? And the coin was bumped just a little bit. And this one spawns our mushroom. Our mushroom also uses that bump method. It comes out the box, and it uses that patrol component to basically move itself right off the screen. Awesome. So now that we've got our coin boxes ready for use, they are headbuttable, and we've got our nice little items coming out and doing some cool stuff with that. The next thing we're going to implement is a special custom component for Mario himself. And this component is going to be quite lengthy and have quite a few methods on it. So let's go ahead and go through that. So down here we've got a custom component for Mario. Mario component. Right, so it is quite a lot, like I said, but it will definitely make sense. Nothing too complicated going on here. So let's just briefly go through it. So for our Mario custom component, we're going to require a couple of other components. We're going to need the body component to basically check if Mario is currently in the air or on the ground. We're going to need the area component as well so that we can check the collision area around Mario, essentially, depending on whether he gets big or he gets small, because that's what we're going to be doing here. We have got methods to make Mario bigger or smaller, and we've got variables to keep track of those. And basically, if we do call either of these, we're just going to set the current width and height of the current pixel, bigger or smaller. We've also got methods for standing, jumping, and running. And these all use the tracking variables that we've created up here to basically call custom animations from our JSON file. And that is the reason that we need our sprite component as well, because we need to reference that file to basically set the correct sprite depending on whether Mario's big or small, or whether he's running or standing, etc., etc. And we're also going to need our bump component, because we're going to use that in our die method over here. So if Mario dies, we're going to unuse the body component. We're going to call bump to basically bump Mario out the screen. We want to set our isAlive to false, obviously. We want to freeze him, so that's just going to set isFrozen to true, which will mean that Mario can't move anymore. We want to do that if Mario dies or if he has reached the end of the game. And if Mario does die, we want to use this cool lifespan method to basically fade him out of the game. A couple more important things to note about the Mario component is that we also have an update method which runs on every frame, remember? And we want to check out isFrozen. isFrozen is true. We want to call standing, and standing will basically set Mario to use the correct animation, which is referenced from the JSON file. If you look over here, we've got small animation and big animation, which reference our frame tags in our JSON file for the correct animations. We're going to do a check on grounded over here to check if Mario is currently in the air or on the ground. And basically, if Mario is not grounded, then we can use our jumping method over here. And that is going to allow us to use our sprite animations for jumping as well. And finally over here, we've got to check for if our key down is left or right. Then we want to do our running, because we can only run left or right. So if either left or right is being pressed, we want to call our running to do our correct animations. Otherwise, we just want to call standing, because obviously Mario is just standing in one place. Cool, so I think that should cover it for the Mario custom component. Let's go ahead and go back to our main config file. And you can see that in one of our tags, specifically our P tag, which is the player tag, which is of course for Mario, we just want to uncomment our Mario call, which will enable our custom component. So let's give our project a run and let's start our game. And you can see now that Mario's running around, he's jumping, we've got really cool animations going on. Nice, it's referencing our sprite file and all our checks are working. So that's giving the illusion of Mario running around. And let's headbutt this mushy. Nice. So we still need to do a check for Mario against the mushroom. So let's go ahead and worry about that. So we can go back to our main scene and we've done this headbutt check over here. Let's do a line or two down from there and add this. So we've got an onCollide attached to the player object. We're checking our big mushy tag. And basically, if we collide with a mushroom, we want to destroy the mushroom and we want to call our bigger method on our Mario player to make him get bigger, right? So let's go ahead and save this and start our game. Let's get this mushy. Nice. So we eat the mushroom, and you can see that now Mario gets bigger. So the next thing we want to worry about is the case of Mario dying. If you remember in part 1, we had this collision detection here for Mario on a bad guy tag, which allows Mario to squash him. So I'm just going to replace this with our updated version here. So basically we're still doing the same thing. We're going to check basically if Mario has the can squash ability. We will squash the baddie. Otherwise, we're going to check basically over here. If Mario is big, we want to set him to smaller again. That's basically like having 1 life. If you're at all familiar with Mario, you'll know that once you eat a mushroom, you can become big, and that will give you an extra life. So 1 more life before dying. And if we don't have is big true, that means Mario's just small. So unfortunately then Mario will just be killed, and we have not created this killed function yet. So of course we need to do that. So let's go ahead and implement our killed function. So we can just go down here and say Mario killed. Okay, so we have a function called killed. So unfortunately Mario is dead. And we are doing a check in here to say if the player is alive is false, we want to return. So that's basically just the case of Mario already being dead. So of course we don't have to do anything if that is the case. So we're going to call our die method over here, which, if you remember, is a custom method on our custom Mario component. And that die method will cause Mario to unfortunately die. And we want to add a nice game over screen here. And basically we're going to use the wait method. And we're just going to wait 2 seconds before we go back to our original start screen. So that is our killed function for Mario being killed. Now, another way that we could die in Mario is if we fall off the screen. So we've handled the case of if we run into an enemy, we're going to trigger our killed functions. So our main killed function and then our die method inside our Mario custom component, obviously. If we go back to where we are doing our initial on update for our player, we are checking a couple of things relating to the player's position and the camera for our camera scrolling. So I'm just going to replace this with the updated version here. So essentially we're still doing our camera checks to check the current position of the player and moving our camera along with our player, but we've added an additional check over here to basically check if Mario has fallen off the screen. So we're doing this by using the Y position of the player object, obviously. So if that's greater than the height of the screen, which we can use by just calling this height method here, then we want to call our killed function again because Mario has fallen off the screen, right? And then our killed function will run, and that will also call our custom die method on our player object. One other thing that we'll need to take care of as well is, if you remember in our Mario custom component, we have an isFrozen variable. So we need to make use of this in our left and right direction handlers. So for our on key down events for left and right, we're going to add the following check. We're just going to say if our isFrozen variable on our player object is true, then we just want to return. So that will prevent us from moving left or right. Nice, makes sense. We also want to only allow Mario to jump if he is alive. So we can just modify our space handler, our space key press handler over here. We just want to add the condition that Mario is still alive, right? So we can just say player is alive. So as long as that is also true, then our player grounded is also true, and this is also true, then we should be able to jump, because obviously Mario cannot jump if he is dead. So I believe we hopefully have all of our logic in place for if Mario is killed, if Mario headbutts a question box, whether it's a coin box or a mushroom box, a coin will be spawned or a mushroom will be spawned. And if we collide with an enemy, we should have Mario be killed. So let's go ahead and save our project. Let's start our game. Right, so Mario's running, animations are working. Let's kill the baddie, and let's get the coin. Let's get the mushy. Cool, so we get bigger. Let's try make this jump. Ooh, nice. So let's keep going. And let's test out our death. So you can see Mario is killed. We get a game over. We wait 2 seconds before going back to our start screen. Nice. So we're getting there. The final thing we want to take care of is the case of when Mario reaches the castle. So if you look over here, and if you reference in our level configuration object, we specify a capital H for our final destination, or the castle, or our home. And you can see over here that we're using the area method to specify a width of 1 and a height of 240. So that's going to create a nice long line over here to represent our final destination point for Mario. And this is going to allow us to check whether we have reached the castle. So now that we understand how that's going to work, let's try to implement that. So we're going to go back to our main scene. And we've got our headbutt collision here. We've got our mushroom collision there. So let's go under here. And let's say castle. So that's obviously if Mario has reached the castle. We need to add a collision method, which is attached to the player object. So we want to pass in this arrow function in here. So when we reach the castle, we're going to call our freeze method on our player object. So if you remember our freeze method, that's just going to set isFrozen to true. So basically Mario cannot move. We've handled that already inside of our key handlers. So we want to freeze Mario if we hit the castle. We're going to add a nice, well done text right in the middle of the screen. And we're basically going to use the wait method over here to wait 1 second. And then we're going to go to the next level. And we're going to do that by setting a variable called next level. And that will be equal to the level number plus 1. Makes sense. And we're just going to say if the next level is greater than or equal to our length of our levels array. Remember, we have our levels array up here, which has 2 levels for now. So you can obviously try to add more levels in there if you're feeling up to it. That could be a fun thing to do. So it seems like we have our logic in place for the case of the player reaching the castle. Basically, we're doing the wait method here and we're checking if there is a next level. We're going to go to that level, right? Otherwise, we'll just go back to the start of the game. Alright, cool. So let's give our game one last test with all our recently implemented logic. Cool, so we're on level 1. Oh, wasn't a great start. Let's try again. Oh, got him. Let's get our coin. Let's get our mushy. Yeah, he gets bigger. Let's make this jump. Nice. Let's get this guy. Got him. Get some coins there. And we are going to reach the castle. Well done. And now we are on level 2. Nice one, guys. So we've built a pretty well-functioning and pretty true-to-life Mario game with JavaScript and Kaboom.js. I hope you guys really enjoyed this tutorial, as I certainly did, and I hope you all learned something. Thank you very much for watching, guys, and I'll see you all in the next one. Hope you have fun with this, and goodbye. Thank you.